Today's video lesson is how to determine whether or not triangles are congruent using the 5 methods that we discussed in class. So let's go ahead and list them out. Listing the theorems are going to help you identify whether or not they're congruent. So I'm going to start with side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, and then last we have not congruent. Remember, not congruent is always an option. If it does not follow one of those 5 on the left, not congruent is your answer. So the first thing you're going to do is kind of focus on your triangles. There are 2 triangles in this picture. You have a triangle here, and then you have a triangle on the other side. It is very, very important that you can see the 2 triangles that you're focusing on. If you can't see them, you're not going to be able to compare them. Remember, the first 4, these work on any type of triangle. Hypotenuse leg is only for right triangles. Now, that doesn't mean that I can't prove a right triangle congruent using angle, angle, side. It just means that I can only prove a right triangle with hypotenuse leg or any of these other options. Right triangle works for all of them. The other types are only the first 4. So what we're going to do is draw on our picture. I've told you so many times to draw on your picture. Please listen to me. Draw on your picture. This is visual if you draw. I know if this side's 90 over here, that this side is 90. So to draw on your picture, bars are sides, curves or boxes are angles. So this is a side, so I'm going to put an S here. This 90-degree box, that's an angle. I'm going to put an A. And I'm going to do that over here as well. For them to be congruent, it must follow the pattern in both triangles. Now, referring back to your notes, when the triangles are side by side, they share a side through reflexive property. This segment or side is in the yellow triangle and it's in the green one. So it's congruent to itself using reflexive. In order to determine which of my options I'm going to use, once I label, I'm just going to cover up one of my triangles because I'm not going to use both of them at the same time. Just cover one of them up. It should spell out the triangle theorem for you. Notice how you have 2 sides and 1 angle. So I'm going to go through and mark out my options that don't work. Most of you can see it, but if you can't, all you have to do is just kind of spell it out. I've got 1 angle. Well, side, side, side requires that I have 2 angles, or no angles. ASA, I need 2. Angle, angle, I need 2. On hypotenuse leg, I have information about a leg, but I don't know anything about the hypotenuse, so it's out. So all I have is side, angle, side, or not congruent. Well, the angle is between the sides. So my theorem, a method of proof, they're going to be congruent by side, angle, side. That's kind of the thought process that you want to use for all these triangle proofs. You want to make sure that you're drawing on your picture. It is a very easy concept, but if you don't draw on your picture, you will do it wrong. All right, let's try the next one. So I'm going to kind of just erase what I did over here so I can use it again. See, that's the benefit. Write it in pen, erase it in pencil, and then you're good. All right, so again, in my mind, I should see 2 triangles. I should see a triangle over here, and I should see a triangle over here. Okay, I'm going to start labeling. Bars get S's, curves get A's. All right, so far I just see a bunch of sides, but if my triangles are pushed together and they share a side, that means you know information about a side. And this one is the easiest because it's all S's. So if I cover up one of my triangles, S, 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 side, side, side. This really just comes with practice. The more times that you do these problems, the easier they'll become because you're actually writing on them. All right, let's try the next one. Again, hopefully in this problem, we easily see 2 triangles. That's very important because they're separate. Now, the only time I can add info to my picture is if my triangles are connected in some way. So in the first example, they're connected by a side. Further down, they're connected by angles. That's the only time I can add info to my picture. Other than that, I'm kind of just stuck with what it gives me. So looking at our problem, let's go ahead and label. S's get sides, or sides get S's, angles get A's. Well, narrowing down our choices, I have at least one angle. So side, side, side is out, and so is ASA. And this is not a right triangle. So I'm going to cross out this one, this one, this one, and this one. Now, some of you are going to be like, oh my gosh, it's side, angle, side. But you have to look at the location of the angle. Is the angle between this side and this side? No, it is not. And we don't write dirty words, so it's not that theorem either. So my reason here is not congruent. Angle side side is not a method to prove triangles congruent. The angle has to be in between the sides, and in this case, it's not. Hopefully we're getting the hang of this and we're seeing it a little bit easier. So I'm going to go ahead and rewrite all those again so I don't have to keep scrolling up. If you take the time to write it down and use process of elimination, it's going to help you. So again, these triangles are not touching in any way, so we should easily be able to see the two of them. Curves get A's, bars get S's. I see a curve, that means that's an angle. Double curve, angle. Bar means side. It's just proper notation we learned the first day of school. I'm going to go over here, A, and S. Using my process of elimination, I notice I have two angles. So anything without two angles is not a thing. Crossing it out. Then it's just you determining where the side is located. So this one, I've got two angles and a side. Is the side between the angles? Well, if I look at A and A, there should be an S here if it's ASA. And I don't see ASA. So that means it's angle, angle, side. So my method of proof, angle, angle, side. I'm going to zoom out so we can use the same little chart. I'm going to erase what we just did. Again, these triangles are separated, so hopefully we can easily see two of them. Curves get A's, bars get S's. Curve, A, bar, S, double curve, A. Curve A, bar S, double curve A. Angles are represented by curves, segments are represented by bars. So now I'm just going to go through my options. Again, two angles. So when I'm going through my list, side, side, side is out, side, angle, side is out, and this is not a right triangle, so HL is also out. Is the side between the angles? Yes, it is. So it's angle, side, angle. Notice the difference in the notation in these two. The side was off to the side in this one. The side is in between the A's in this one. If you draw on your picture, you will see all of the properties and theorems that you need, but you have to use your picture. All right, let's try the next one. I'm going to leave that up here so we can see this. So again, curves get A's. This is another way to show congruent angles. Instead of duplicating the curves, you can use bars. We don't use that notation, and that's okay. So this is A, and A. I should stop here immediately. Angle, angle, angle is not a thing. I know you want it to be because side, side, side is a thing, but AAA is not. So right here, it should let you know not congruent. None of these options have three angles. All right, let's go ahead and do the very last one. Bars get S's and curves get A's. Now, I don't see any curves here. However, this is a bow tie problem. At the bow tie, put angles. So here is the bow tie part where it connects. I'm going to put curves. So that's my angle. My angle is between two sides, side, angle, side. Let's go ahead and do real quick a hypotenuse leg. Okay, so let's go ahead and do a hypotenuse leg problem. I didn't add one on this worksheet. I'm sorry. So let's go ahead and just We'll just add it down here. So a hypotenuse leg problem could look like this. So you could have a right triangle with a 90-degree angle. Your legs would be congruent and your hypotenuse would be congruent. Hypotenuse leg. So this would be HL. Another way you could see it is you could see it like this, where you have your 90-degree angles in the corner. And this one is a little harder to see. So what you want to do is you want to make sure that you box in and highlight your triangles, because when they're adjacent like that and sharing a side, they're harder to differentiate between. So if you have a problem that looks like this, and let's say that you know that this piece and this piece are the same, you still can use reflexive property, letting you know that the hypotenuse is a part of both. So again, hypotenuse, leg. If it's not one of those 5 theorems we talked about, it is okay to write not congruent. Not every single triangle in existence is always congruent to something.